Hello everyone. So once again we are back. So in last session we have discussed till stack and we continue from there. So okay, the first question is that we have to cover, that is like one of the most famous and one of the most generic question that is asked asked in like stack question, that is the check the balance stack. Okay, balance parenthesis. Okay, parenthesis using stack. So like the problem like so what are the question states that, so we the string is given in which this thing is happen, like parenthesis, this curly bracket, and another is the square bracket. Okay, this is square bracket. So like determine whether it's balanced or not. So it will, we see from this thing is that this one is balanced, this is like open close open close open close. So this is a balanced string. So what is the code and how we write the code for this one? So let's see, let's write the code. So okay, so initialize all the things like import java dot util dot star. Okay, we like export and imported all the libraries, and then again we have to write a public class main. Okay, public class main, and inside this we have to like public public static void. Okay, so public static void, or in that case we have to return whether it is like valid parenthesis or not. So in that case we have to like simply return true or false. So in that case what we have to write, so for this condition we have to write like boolean. Okay, boolean inside this one, boolean, the name is that is balance, balance thing is that, and the thing is that this string is given. So string s is given. So then write the code. So first of all we have to initialize the stack. So stack is initialized. Okay, in which we have used character. Okay, so st and new stack, stack, keep it. Okay, so in this we keep this one. Okay, so okay, we have to like search for other things, that character over. So this is a string, we have to travel on all the strings. So in that case what we have to do, so we have to like convert that string into the characters array. So s into the to char array. Okay, so you convert it into char array. So if we see any of this character like ch is equal to this one, so like closing like only this one, or like curly braces, I simply taking two things. Okay, ch is equal to this thing. Okay, opening one. Okay, so in that case you have to push this thing into stack. So st dot push into the stack. Okay, and else if stack is empty, return false. So and another else case is that if stack is empty, so st dot is empty. In that case we have to simply return false. There is no parenthesis inside this one, or inside case if the character is this one closing thing, and and the top, and so we find things like character that is top. So like st dot st dot top. Okay, okay, st dot pop, pop inside this like a value of the top element. And if we check, if we top and this top is not is equal to, that is this character. Okay, so top is not is equal to this thing. Okay, so in that case we have to return false. Okay, The same thing goes for the like other things. If these things are not there, if these things are not there, okay. If these things are not there, we simply return st dot return st dot is empty. If empty, it will definitely pop it. Okay. Okay. So that this is the like boolean. So if we write into the public static void main string arg, so you have to like pass this and pass this string. Okay. Okay. So in that case, we have to check the values parenthesis. Okay. The complexity is order of n. Okay. So next question that is that we have to uh, design the mean stack. Okay. We have to design the mean stack. Okay. So mean stack is composed with the all the things that we needed that are push okay, pop, top, and like get mean. Okay. So these are the functionalities of the stack. So all we have to do into this like order of one. Okay. So in that case, what we have to do? Like, okay, so what we have to do? First of all, we have to size, okay, code. So we have to import all this thing. Importing thing all is there. The class is like stack. Okay. So first of all, we initialize one stack in which have integer. Okay. Integer. Okay. So st is equal to okay. Another stack that is mean stack. Stack that is integer. Integer that is mean stack. Mean stack that is then okay. So we initialize two stack for designing this mean stack. So next step is that we have to write for the push operation. So like void public void. So public void push operation. So in this we have integer value. Okay, integer value inside this one. So like in that case we have to like push the things. Okay, so st dot push what value. Okay, in push operation we simply push the value. Okay, another case is that we have to like pop push the value and what for the mean stack. Okay, so in mean stack, if mean stack, okay, mean stack that is mean stack is empty. Okay, mean stack is empty and that value is less than is equal to mean stack dot top mean stack dot peak mean stack dot peak. Okay, so if we find this value, so in that case we have to push this value mean stack is empty or like value is lesser than this one. Then that mean stack dot push that value. Okay, this is for the pushing value. Okay, and when let's move for the pop value. So public void pop. Okay, so how we pop the value? Okay, so pop is like simple. So if that st dot top st dot pop st dot pop dot equals to mean stack dot peak. Okay, so however if st dot pop is dot equal to that mean stack peak. So in that case, mean stack dot pop. Okay. And what is the operation for the public integer? What is the top value? In this case, we have to return some value. So if this is a simple case, so it simply return the st dot p. Or how we find like minimum value. So in that case, public integer get mean. Okay. So in that case, return mean stack dot peak. Okay. So through which we can like mean stack. If we want to like get minimum in mean stack, we have two stack value. Okay. So like we have to one stack and another is a mean stack. Okay. So this value is like how we put inside the value. So it value putted. So like 2 is putted. If this value, if this is empty, we fill in inside this one. So if we see any value like 3. So if we see any smaller value than 2, we can put here. Okay. So if we want to find like any value from the mean stack, so we simply at peak this value. So this value, this statement is from here. So if you want like mean stack dot peak, if we want the top, so st dot peak. So this is the step to find a st dot peak. So if 2 is here and 2 is here, so in that case, st dot pop and this empty dot peak is same. So in that case, pop the value. Okay, mean stack value. Okay. So this is how we like design the mean stack. Okay. So another question is that the real world use case of the queue. So now we have to move to another like data structure, that is about queue data structure. And what is the real world uses of queue? Okay. So we are talking about queue data structure. Okay. So what is this? It stands for the like FIFO, first in, first out, where we use like printer queue, CPU scheduling, ticket booking system, call center management, order processing, BFS traverser, message queue, banking token system, all these things. Okay. So first come, first serve. Okay. So that's, so we have to implement queue using two data structure. So in that case, we have to like design. The question is that I have to design. So design a queue using two stack. Okay. Two stacks. So how we design the two from using two stack. So let's see. First of all, like in so we use two stack. To design the queue. So one stack do insertion, another stack do deletion thing. Okay. So let's write the code. So for this one. So like importing and all this thing will be, we can do later. Okay. First of all, write the thing like stack of what we have. So integer, we have to design this queue now. Okay. st1, that is, and new stack. Okay. So I initialize the stack. Again, we have to write stack. Okay. Integer type. Then I is capital. Integer. Okay. st2. Okay. New stack. Okay. So I initialize the two stack value. Okay. So first of all, I have to enqueue, like I have to push the value. So like for the enqueue public void enqueue. So in that we have some integer value. Okay. So in that integer value, so st dot push the value. Okay. That is x. Okay. So st dot to one value. Okay. And if you want to dequeue the value, so it can be deleted from the stack too. So public void dq. Okay, so simply like dq. So in that case, if we check that if st2 is empty or not, so is empty or not. Okay, so if it is empty, if this is like true, so in that case we have to delete all the value till st.1 become empty or not. Okay, in that case we have to remove the value from the this one. So till st1 become empty, we have to push the value into the stack 2. So st2 dot push in st.1 dot pop. Okay, okay, and finally after all this thing value, while loop, after finishing the while loop and all this thing, we have to return. Okay, in that case, okay, in that case, we have to like return the stack value. So like stack to value. So I design a queue using using two stack. Okay. So like also we have to like design the rate limiter using the queue. Okay. So like how we like design a rate limiter using the queue, right? Queue data structure. So let's see. So next thing that we have to uh, design 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 a rate limiter using using the queue. So how I design? Okay, for this thing, first of all, first of all, we have to like rate limiter things. Okay, so in that case, first of all, initialize the q value. Okay, so q is equal to qut. Okay, invest long value is there, so simply like long. Okay, that we call q u new. In that case, I have like linked list. Okay, and in that publish boolean permission, like use boolean for allow request. Okay, public boolean. Okay, allow request the long current. So in that case, what is the current value in network? Like a system dot current time mainly is. Okay, so by this one we can find this like current time. Okay, okay, then we run while loop if q is not empty and current minus q dot peak is greater than some value. So in that case, q dot pool. Okay, if q size is less than 3, in that case we have to like push the value, that current value, or return true. Okay, so simply we have like if while loop while loop if q dot is empty, So and this current value minus the q dot peak the value, that is value is greater than is equal to 1000 something. In that case, what we have to do, like q dot pull that value. Okay, pull that value. Otherwise, if q dot size is greater than 3, in that case, what we have to do, in that case we have to push the value of for the current value, otherwise, and return true, otherwise return false. Return false. So this is the way we can design a rate limiter. Okay, so the next question is that how does the hash map work internally? Okay, we have to explain how the hash map work internally. Okay, so let's move to the next topic, that is hash map. Okay, so how this hash map work internally is, first of all, hash map can store the two value, that is like key and value. Okay, so that has calculate hash code like step. So hash code convert the hash into the bucket index, store that enter in bucket and retrieve all the keys. Okay, bucket array have some like nodes, different nodes. So Java 8 optimize the linked list to red black tree, and the when bucket size is greater than 8. Okay. So like we understand that hash map have some value, so this will like store. So if we see, this is key, this is value. Okay, so A occur 2 times. Okay, B occur 3 times. Okay, C occur 4 times. So this is the way you can say that. So what happen if two key have a same hash code? So if a two key has the same hash code, so this like if we have map dot so map dot put like key one having some hash code of 100, and if map dot put key two have some value like 200. Okay, so 200. So in that case, if both having the same, so like if both key have same hash code, so if they have both same hash code, so in that it produce same hash. Okay, in that case it produce same hash. Okay, same hash, and this is known as a collision. Okay, so Java use linked list before this one, and in now it use red black tree. Okay, so hash code same is equal not is equal to object same. Okay, so if hash code is same, okay, so if hash code is same, it's not is equal to that the object is same. Okay, so the object are different, not is equal to object same. So these are two different things. Okay, so how we find a duplicate element in the hash map? So we have to find duplicate element. Okay, element in duplicate element using hash map. So hash, that M is capital. Okay, So how we like find duplicate, how we find duplicate element in the hash map. So this one is pretty simple question. Okay, so like what we have to do simply, that's the code for this one. So if first of all, the thing is that first of all we have to like create the hash map. Okay, so hash map map, we want to store integer. Okay, so this is MP, we call as a MP is equal to new hash map, close this one. Okay, so I initializes the hash map. Okay, initialize the map and store all the value. So for int num from the all the array, so what we do, we have to put this value. So map dot put, this nums, we have to put nums, or like how we put this value. So map, so mp dot, so like we like map. Okay, given name as a map. So in that case, like map dot get, get or capital or default. Okay, we check the values. So num comma 0 plus 1. In that case, I incremented the value. Okay, then after, then after I check inside the key. So for auto integer, that is integer key over what, map dot dot key set. Okay, we have to key set. When we have to move on the map, we have to write like map dot key set. Okay, and then if map dot get key, like map dot get, if we get the any value of the key value is greater than 1, so in that case, this is like return that key. So this one is the like, this one is the duplicate element. Okay, so this thing like, thing is like different from the like Java's, like C++ is this thing is that. So like want like some blue color, dark, not dark, this is, if you want this. Okay, okay, so in that case we see that these things are the different thing. And map, we simply like a key over the map and get key in simply set map of that value if it greater than 1. So in that case return this one. Okay, so these are the things we have to keep in mind. We have to find that duplicate element in the map. Okay, so this take order of n time, and space complexity is also order of n. Okay, one of the hard question is that you have to design LRE cache. So LRE cache take times. Okay, it a limited size, remove the least, so like this mean that browser cache limited size, I remove the least recently used page. So in remove the least recently used page, and the data structure that I use, that is hash map and the doubly linked list. Okay, so maybe interview asks for this question. Okay, so what is the difference between hash map and the hash set? Okay, so this one, hash set versus hash map. Okay, hash map. Okay, so like hash map, so we can say that the hash map store only value. Okay, only value. In this case, like only value is stored. Okay, but in this case, that we have to store like key plus value. Okay, so in this two things is like key and value. Okay, and null value is not allowed. So any null value is prohibited, but duplicate is not, like duplicate it not allows. Okay, so like one null value is allowed, duplicate is, sorry, null is allowed, one null is allowed, one null is allowed, but duplicate is not allowed. Okay, net set duplicate is not allowed. Okay, Okay, so if we want to add, like, if we want to add, so in that hash map, what we use. So if you want to add any value, so in that case, I use like map dot dot put that value. Okay, put that value. Okay, so if you want to add something, so we have like a set dot add some value that x we have to add. So in this way, and this is the different way. Okay, these are two different way to add. So I think that we covered till here. So okay, thank you for joining the second session of the data structure discussion, where we have discussed till hash map, difference between map, and let's see what are the next question we have to see. So next question is that to find whether the array contain duplicate or not. So we can find using hash set. So how we can say that, like we create the hash set. So okay, let's write the question. The question is that how to find, how to like, text. Okay, so it's not working. Everything is working. Okay, so in that case, what the code have to write? I have to find a duplicate element in the array. So in that case, we have to initialize the hash set. Okay, hash set of like integer value. Okay, and this is like set, call set, that is new. This is a new hash set. Okay. New hash set. Okay, for this value int num over this array. This nums over the array. Okay, in that case, what we have to do, if this set contain dot contain this num value, then this num. So if set contain this number, in that case we have to return false, return true. So this is a containing any duplicate value. Otherwise we have to add this value. So in this set, add that num. Okay, and return false if we don't contain, if we don't find any duplicate value. So in that case, we have to return false. Okay. Okay, and then we move to the binary tree and then binary tree and the graph. Okay, so we leave this session here. And what the question, let's read the question. What are the next question that we have to discuss? Like difference between binary tree and BST. Okay, so it's simple, like binary tree is any arrangement left, right, and all any value. But in the binary search tree, like order structure, left, root, right. Okay, in that order of n, but in the binary search tree we take log of n. And how to find the height of the binary tree? Like simply the longest path of root to leaf is known as the height of the binary tree. So in that case, if we check that root is equal to null, then return 0, otherwise 1 plus math dot max. So height root dot left, height root dot right. Okay, in that case we can find the height of the binary tree. How we validate whether the tree is BST or not? So for that case we have to write some code. So node value less than mean, node value greater than all this thing, and also find the lowest common ancestor. So in that case, we first of all we have to always check edge cases. Okay, if root is equal to null and root is equal to p or root is equal to q. Okay, so in that case, root is the only element. So in that case, we have to return root. Root is the only ancestor. So if the if you want to search on the left subtree, so like a root tree node left is equal to lowest common ancestor, and we have to point that area. Root dot left is like become the root node, and the p and q again we have to search. So again same for the right side. Okay. And one more thing, that if left is not null, right is not null, so then if left is not null and right is not null, then in that case root become, then return the root. Okay. Otherwise return root is not null. If root is not null, then left is equal to right. Okay. So why do database use B tree instead of BST? So basic question. So like BST problem can become screwed, become one-sided. So height can become order of n and may like increase. It take more disk size to access these things. So advantage is that B tree is balanced, fewer disk read, and store multiple keys per node. Okay, efficient for the large databases like used in the SQL and the Oracle databases. Okay. And how we find the k largest element in the array. So like finding the k largest element, now we reach here to the priority queue things. Okay, so in that case we have to use mean heap. For that case we have to initialize like priority queue integer pq and new priority queue. All this how we initialize it. Remember that p is capital, q is capital. Then in queue how we push, like pq dot offer that number. Okay, if pq size greater than k, then pq dot pull. Okay, if pq dot size greater than some k value, if you want to like extract some like k value, so okay, so like we have to like this 1 2 3 4. Okay, so we want like k largest element. So in that case if we fill any extra value, we have to remove this value and this value become the third highest number. Okay, cool. And return, and we have to return first k largest number. So in that case we have to like return in the array list. So return new like array list of that thing, that is pq. Okay, we have to return the in array list form. Okay, we take our order of log and temp. So explain the priority queue in the Java. So how we write priority queue? So if we want to write, write for the mean heap. So if I have to write for the mean heap, so how I like write? So in that case, you have to simply write P capital. Okay, priority, this priority Q capital. Okay, and so if any value, if you want to take integer, so like integer, and then for the priority queue you have to like pq. Okay, same new like priority queue, this thing. So the way I initialize is this mean heap. Okay, so this is mean heap. So if you want to like initialize the max heap, so in that case in max heap the thing all thing are same, like this thing are same. After new we have to write like this one, like no, inside this one you have like collections dot reverse order, that reverse order for capital. So in that case we have to like initialize the max if and like put this value. Okay, so design a system to continuously track top k highest salary. So in that case like when we ask to design a system where continuously track the top k highest salary, so in that case you have to simply write that the priority. So like prior p capital. Okay, priority under q q e. In this we have to like put integers. Okay, pq. Okay, new dot priority, like priority q capital q u e integer like this one. Okay, this is like initializing the max heap, like mean heap. Sorry, mean heap. Okay, So run over the salary with sal over salaries array. Okay, PQ dot offer what sal. Okay, and if PQ dot size is greater than 10, then it become, we have to like PQ dot equal. Okay, okay. So this is the way we can find the top 10 highest salary in the list. Okay, inserts in order of log 10, like many parole system, all this thing. Then in the next session we have to discuss of the graph, that is like BFS, DFS. Okay, so till now, bye bye.